Day 3, we're going to look at writing linear inequalities, which is pretty similar to, we look at writing systems of linear equations, so inequalities is almost the same. So warm up with your team, complete the following. Seniors in a student council of a high school are trying to come up with a budget for the senior ball. Here's some information they have gathered. Last year, 120 people attended. It was a success and is expected to be even bigger this year. Anywhere up to 200 people might attend. There needs to be at least one chaperone for every 20 students. The ticket price cannot exceed $20 per person, and the revenue from ticket sales needs to cover the cost of the meals and entertainment, and also make a profit of at least $200. Okay, so let's do the first one. I'm going to highlight here. 120 people attended last year. It's going to be even bigger. Up to 200 people might attend. Okay, so here is the matching one for that one. So the number of people, P, will be anywhere from 120 up to and including 200 people. All right, let's try the next one. There needs to be at least one chaperone for every 20 students. Okay, so that would be this one right here. The chaperone has to be greater than the number of students divided by 20. Okay, the next one, the ticket price cannot exceed $20 per person. That would match that one right there. And then the revenue, so by process of elimination, revenue needs to cover the cost of the meals and entertainment and also make a profit of at least, there's that $200. So it's the price of the ticket. If we write this out, P is the price per ticket times number of people. This is the profit, minus the number of meals has to be greater than or equal to $200. Oh, okay, so determine what is meant by each letter. T is the number of tickets. Whoops. P is the number of people. And C is the number of chaperones. Okay, so those ones, they wrote the inequalities for us. So now we're going to see if we can come up with inequalities for each situation. So the first one, an elevator, car, and a skyscraper can hold at most 15 people. For safety reasons, each car can carry a maximum of 1,500 kilograms. On average, an adult weighs 70 and a child weighs 35 kilograms. Assume that each person carries 4 kilograms of gear with them. Okay, write as many equations and inequalities as you can think of to represent the constraints of the situation. Be sure to specify the meaning of any, okay, so let's say P is number of people, and this elevator car, okay, I'm going to, E for elevator can hold at most 15 people. So the number of people in the elevator, so P is people, the number of people has to be less than or equal to 15. All right, so there's my first one. Number of people less than or equal to 15. For safety reasons, each car can carry a maximum of 1,500 kilograms. And you have the adult and the child weight, but each person carries 4 kilograms of gear with them. So we're going to add that actually to each of these right here. So we're going to say 74 kilograms per adult plus 35 plus 4, 39 per child. This weight has to be less than or equal to 1,500 kilograms. So I think that these would be my two inequalities to write for this one. Again, the number of people less than or equal to 15, and then you have your adult plus your child weight should be less than or equal to 1,500 pounds. Oh, but number of people is adult plus children, so we actually could change this to the number of adults plus the kids. It has to be less than or equal to 15. Yeah, I think I would be satisfied with those too. All right, let's take a look at the next one. Trade, work with your partner, and read each other's inequalities. Okay. All right. 3, write your equations and inequalities so that they would work for a different building where an elevator can hold at most 10 people. Each car can carry a maximum of 500. each person carries, okay, so very similar, but the weights are different. So 10 people. Okay, so adults plus kids, less than or equal to 10. And then 2 kilograms of gear, so we have to add 2 to this. All right, so it'd be 72 and 37. So adult is 72 kilograms. Ooh. Plus kids weigh 35 plus 2, so 37 for each child. Has to be less than or equal to 500. So there would be a system of inequalities for this right here. Okay, so really that's it. I mean, can we practice solving an equation? So your assignment is going to be a few things. Solving systems, I'm sure we'll have some review with that, but also can you set up an inequality? And so let's pop up an example of what the assignment might look like. All right, so I'm going to pop this up. We're just going to try to match it. It says a rental car company charges $44.33 per day to rent a car and 9 cents for every mile driven. Isaac wants to rent a car knowing that he plans to drive 200 miles and he has $500 to spend. Which inequality can be used to determine D, the maximum number of days he can afford within his budget? Okay, so he has at most $500 and he has $44.33 per day plus 9 cents for every miles driven. Okay, so this is the slope. So we're looking for like miles. Oh, and he plans to drive 200 miles, so 200 times 0.09. That will be, that's the 18 that they're getting. Okay, so $44.33 per day, that will be our slope, plus the $18 for driving 200 miles. Okay, so we're taking a look at matching it up, and I think it would be this one, right? So again, this cost, it should be less than actually. Let's change it. So what we're trying to spend should be less than or equal to 500. It's going to be $18 for all the mileage plus $44.33 per day. So let's check that answer. Okay, let's try another one. Noah needs to order some new supplies for the restaurant where he works. The restaurant needs at least 503 knives. There are currently 391 knives. If each set on sale contains 10 knives, which inequality can be used to determine the number of sets of knives that Noah should buy? Okay, so this one we see the 503, and what we want to spend, we need at least that many. So we're looking at either the first one or the second one, because what we're spending is, or getting, is at least that amount. Okay, so it's between these two. Where does the X go? And there's 391 knives currently, and then each set on sale is 10 knives per each set. So that, I think, is what's changing. The input would be the number of sets, so I'm looking at this one right here. Let's try that, if it would click. There we go. Okay, let's try one more. Caleb has $800 to spend at a bicycle store. He buys a new bike for this much. He buys 3 bike reflectors for this each and a pair of bike gloves. He plans to spend some or all of his money he has left to buying new biking outfits. Okay, so the biking outfits is what's changing, and he can only spend $800 total. So what we spend is less than or equal to 800, so we're looking at one of these two. And if we add 252 plus 3 bike reflectors and the bike clothes, that'll be the 322. And then the clothing is what is changing. So it looks like it's going to be this one right here. Okay, so your assignment really is, can you take these words and write an inequality that stands for that situation?